Like, just keep it right there. See how funny that is?
Hi, I'm Tyler.
Hi, I'm James.
Hi, I'm Nico.
And that guy behind the camera is William. And this is our project on Newton's laws of motion. The date is currently October 21st, 2022. Newton's first law of motion states that an object at rest will stay at rest unless acted upon by an outside force. Similarly, an object at motion will stay in motion unless acted upon by another outside force to stop it. In this demonstrate law, I'll just let it go on. Now, in that demonstration, we had James, the object, sitting on the floor, lying down. As you could tell, he was motionless because no force was acting on him. Now, when Nico came along and dragged him ruthlessly out of frame to his demise, that exerted an outside force on him, causing him to be moved across the floor. This relates to Newton's law, as James, the object, was at rest until an outside force acted upon him to make him move. In this demonstration, Nico, the object, was in constant motion until someone, James, came along and ruined that for him, like he did my third birthday party. Now, this relates to Newton's first law of motion because Nico was the object, endearingly, who was in constant motion, such as the second clause of Newton's first law, and was in constant motion until an outside force acted on him. This outside force caused him to stop and become at rest. That demonstrates, and as you can tell, that clearly demonstrates Newton's first law of motion. I don't know how to add more sentences onto the end of this demonstration. Rest in peace, Nico. Newton's second law states that force is equal to mass times the acceleration. So, in other words, an object with more mass takes a stronger force to move it at the same rate. In this demonstration, I'll go ahead and let you see. So, in this demonstration, James easily moved the small glue stick with ease. In this demonstration, James easily moved the small glue stick with ease. However, when it came to the big old water bottle, his weak baby arms couldn't help him. However, Nico, clearly the stronger of the two, was able to move this with just his pinky. Well, this demonstrates Newton's second law, force equals mass times acceleration, where the bigger objects, well, objects with more mass, we're talking mass here, get it right, take a stronger force to accelerate them the same amount. Another way to demonstrate Newton's laws of motion are two differently massed balls. Whereas, I'm going to throw these with the same force, and the ball with more mass should not accelerate as much. So, let's go. 3, 2, 1. Would you look at that? In that demonstration, as you saw, the golf ball, which has less mass than the metal ball, traveled farther. This is a good demonstration of Newton's second law of physics, because an object with more mass requires a stronger force to accelerate at the same amount. So, when the same force was applied to both of these, one of these moved farther and the other one didn't. Newton's third law of motion states that for every action there's an equal and opposite reaction. So, when you push on an object, it'll push back with the same intensity in the opposite direction. Such as in 1861, when the southern states seceded from the United States because of northern pressure to stop slavery. In this demonstration, now I'll just show you self. As in the demonstration, these two balls were hitting each other with a force that was then met with an equal and opposite reaction that caused the balls to bounce away. The equal and opposite reaction of these balls caused them to move apart. Did you spot the law in the demonstration? It was hiding in plain sight. Really, just us standing here is a great example of Newton's third law of motion. As we're standing on the ground, we are exerting force on the earth beneath us, and it pushes back up with the same magnitude of force, keeping us all from sinking to our fiery demise.